Let's look at how Autodesk Simulation CFD can help optimize your design process. Today we're going to look at an automotive muffler and look at two different cases, one with small holes and internal baffles and one with larger ones. And the design goal is to try to get the most optimized flow in both sides of this muffler so that we get a balanced pressure for better engine performance. Once we launch our CAD model directly into CFD, we can start looking at overall design parameters like internal temperatures and internal pressures within our design. Immediately with our first pass, we can start to see that we're seeing higher pressures on the cylinder on the right-hand side, which of course is our goal, is trying to get the best balance between the two. Another way we can really examine internally what's happening is by use of a cut plane. This is very similar to a CAD tool, where it allows us to cut in through the model and examine any of the internal parameters of exactly what's happening. With this scenario right now, we're looking at some of the static temperatures, velocities, and pressures inside this muffler. And to better examine from one side of the muffler to the other, what we can insert is an XY plot that allows us to pick several points within the model and then create a line that's going to follow between those points and let us exactly plot each of the parameters along this line. So when we pull this line out, we can line it up with the scenario up on top, and once again along this line now we can immediately start to see internal pressures and temperatures directly along that path. The other thing that we can do with this is also to look at the difference between the two cylinders by use of the same cut plane. So what we'll do is we'll insert a cut plane, cut through both of our inlets, and now look at what the bulk pressure is between the two. And we can see with this first pass scenario, we're about plus or minus 4%, which might be outside our windows of what specifically we need for this design. Another way to visualize internally what's happening with our model is by the use of an isosurface. This is a 3D surface of any constant value, and this one we've set at a specific pressure, and we can see once again, and as we set to this higher pressure, we can see the cylinder on the right hand side would see and experience more back pressure than the cylinder on the left. Where the real power of simulation CFD comes in is by use of our decision center. This allows us to compare several design studies within the same CFD model and allow us to look at things like different parameters of varying hole sizes in the model, and also looking at, with this scenario, even two different RPMs, so looking at a case of an idle and while the engine's running at a higher speed. Once again, anytime you've taken any of these images of these runs, we can simply drag and drop into our window, and what you'll notice is the scale is the exact same, the cut's the same, the view is the exact same, and this gives us ideally an apples to apples comparison between every single one of our designs. This allows us to see regions of recirculation by use of a cut plane looking at vectors similar to what we see here, to really once again understand and optimize the performance of our system and to make educated design changes for our next design. Once again, with any of these systems or any of these parameters, all we do is drag and drop. And like with this example, we're looking at some internal traces. So we've released particles from both of the inlets. And now once again, we can easily visualize how the internal flow is moving around and how, as we make changes to our design, we can see the difference in what the performance is going to be. This view allows us to easily see not only the what, but the why of how our system is performing. And once again, this allows us to have educated decisions on making those optimized changes. That same cut plane that we had before, we can plot those pressures out as needed, and this allows us to easily see comparisons side by side of total pressures. Same thing with our XY plot. We can take a look at, on that same XY plot in all four cases, once again visualize temperatures, velocities, and pressures along that line. Finally, once we've got all of our runs set up, what we can do is print out our report generator. And what this is going to do is everything from the title of our project through our table of contents and down to setup for repeatability for further runs, and even all the results from each of our runs in our scenario for easy reporting out after our system's been done.